This is video 8 using PWM on STM32 MicroPython and the BlackPill. The code for this video is at the GitHub site. The information presented in these videos on MicroPython should work as well on any STM32 F4 board. All code examples have pin definitions at the beginning of the file to allow the programmer to alter as needed. As this channel covers multiple microcontroller solutions over time, please subscribe to stay informed and click like, as that really helps. In this video, we are seeking how to use our STM32 microcontroller to perform Pulse Width Modulation, or PWM, to get variable voltage out of a pin. Devices that consume voltage can be controlled with PWM. For example, the brightness of an LED. The BlackPill schematic shows that most pins depicted with the squiggly arrow permit PWM signals. The two code examples today utilize an LED, but we can use the same ideas on, say, an L298 motor controller to control the speed of several TT motors on a robot car. The STM32 F411 baseboard includes onboard LEDs. A cable is connected between the pin B3 and one of the LEDs. Looking at the schematic, we see in the pink boxes that pin B3 is associated with T2_CH2, which is shorthand for timer 2, channel 2. A channel is a way to organize the pins and timer functions. Typically, each timer has up to 4 channels distributed across 4 unique pins. If you choose a different pin, then a different channel and timer is associated. Now, let's open bb_pyb_quicklook_pwm.py in Thony. As discussed, we defined our LED pin and then set up the timer and channel for that pin. For the channel setup, we specify we want PWM. In our main program, we set the channel pulse width % in increments of 10%. Click the green Run icon. The program responds with each % value setting. When the code runs, we watch the LED brightness go from off to fully bright. At the end of the program, we set the brightness to 0 and deinitialize the timer, which cleans the microcontroller for the next program. Click the red stop icon. Now, let's open the second example. Please open bb_pyb_timer-pwm.py in Thony. In the definitions, we add a push button on pin BB10 and a global variable called %. Also, we added a callback routine. This routine sets the channel 2 pulse width to the value of %. In the setup, we associate the callback routine with timer 2, which means it invokes the callback once a second. The rest of the setup is the same as before. In the main part of the program, we print messages of the setup and prompt the user to press the user button. When we press the user button, the program prints the current LED brightness %. Each time we press the button, the brightness increases 20%. Once we reach 100%, the cycle starts over because the % was set to 0. Go ahead and press the run button. Okay, now we will press the push button on the BlackPill. As we do, you can see the LED brightness increase 20%. Once we reach 100%, the next press will reset it to 0, and then it increases again until we do Control-C. All right, do Control-C on the keyboard and click the red stop icon. In summary, setting PWM is easy to set up on the STM32 once you know the pin's associated timer and channel. MicroPython makes it easy to make setting changes and even to associate a callback routine. Hopefully, you now have a better understanding on controlling devices with MicroPython on the STM32 microcontroller. In the next video, we will use a different STM32 baseboard to learn more about NRF24L01 Plus modules. Thank you.